Today, I, Dharya Pandya of CE Department, T1 Batch, is going to explain about the open source Python library, which is OpenCV. Now, OpenCV stands for open source, that's why the name is open, and CV stands for computer vision. Uh, so, OpenCV was designed which had strong focus on real-time applications which are used in machine learning, computer vision, and image processing. It was founded on 1999, and the most important part about the OpenCV is that it works on Linux, Windows, and Mac OS. Not just these three platforms, it is also capable of working with iOS and Android. It also supports C, C++, Python, and Java. Uh, it is supported by Google, Intel, and NVIDIA. NVIDIA has its own NVIDIA CUDA, which stands for Extended GPU. It is also used by the Google Maps, where people can see the street view in the Google Maps. They are used to stitch the images to make the 3D look uh, of an street view. Okay, so now I will explain about the functions that are present in OpenCV. Through OpenCV, we can generally process some image data. We can rotate, we can crop, we can blur the image, we can make the contours. What are contours? I will explain it in the later in this video. Uh, but we can also find out the edges, and through these edges, uh, we can also work on the real time. For example, in a video, as video is a collection of images, so we can also work in a real time video also. The main application of the OpenCV is that it is used to recognize the faces. Uh, in this COVID situation, you might have seen the automatic mask detection. That project is also developed through OpenCV. So now I will explain about the reading an image. Now, first you have to import the civil library in our system, and then we have to import it in our code. So we will write here import CV2. Now first, CV2? Because it's the second version. So if we want to write only the CV in place of CV2, we have to import CV2 and then write as then the name that we have to use. For example, CV. So this is the function to read an image. We will use this function almost every time whenever we are working with the OpenCV projects. This includes the path of the image or the place where the image is stored. Then the function imRead generally reads the image which is present in this location. Then comes the IAMShow. IAMShow basically displays the image in the window. So on executing this program, we will get a image uh, which will be displayed on our display. The arguments of the IAM show stands here IMG, which is the name of the image that we have read through IMRead, and the name of the window, which is cats here in this example. Then comes reading a video. Now, reading a video is not difficult since video is in the form of images only. So we will write here capture equals to video capture the path of the image, and then we have to write here the for loop. For loop, while loop. While loop basically includes it executes till the video gets over. It executes the video frame by frame or the image by image. As video is in the form of an image only, so we will deal with the individual image only. So that's why we are using here while loop. So here, if the loop is true, then we have to show the video and then frame. And then cv.wait key equals to 20, and then this code means that till the D key is pressed, we have to execute the video. Means anytime we will press here the D key, the video will get closed, and we will be out of this while loop. And then we have to close all our windows so this code executes that. Then comes the resizing a video file in a OpenCV. So first we have to import over CV to SCV and then read this image through the function, the imread function, and then we have to use here the define rescale frame, the name of the frame and the scale factor. For example, 0.75 means it will scale the factors as 0.75, and we have to multiply the width of the image with the scale factor as well as the height of the image by the scale factor, uh, and we have to combine them through the dimensions and return these values frame dimensions and interpolation of the inter image in the video. So here it will also, we can here capture the live image through this capture dot set function and also dot capture dot set function. Here it is the same code as we have, as I have explained in the video. It is generally used to read the video from the from our PC. Then if we want to draw any image from the OpenCV, then we can use this drawing in OpenCV. We have to import the CV to a CV and import numpy as np as we are dealing with the array part. And here the blank equals to np.0 500.500.3. Here the main function is the IAMShow function, which stands for blank image. Here the unit 8 is the dimension, it's a data type of an image, and here the painting the image of a certain color, we have to find here the RGB values of an image for a BGR image in particular. Since OpenCV works with BGR, so uh, we are entering the image through BGR. Here we have to find out the length and blank. The rectangle, if we have to show a rectangle in a OpenCV project, then we have to first enter the code for length and then the breadth. And here the thickness comes, and here the color channel or the BGR format, the code which we have to display in the image. Similarly, for the circle, we have to specify the center point and the center point. So we are and the thickness of the image and the color. Similarly, for drawing an image, here the code is for the color channels, and here the thickness comes. For writing any code, we have to write down the text and the name and the text of the image, and we can also specify the font that we are going to use, and these are the output for the same. Then comes the basic function. Basic function includes the converting the image to grayscale. Here we are going to use cv to color. For example, if we are converting a color picture to grayscale, so we are using this function. We can also blurring an image. Blurring an image plays a very important part in OpenCV, since it will reduce the number of edges found. For example, if an image has more of noise and more of degradations, then it can be ignored through blurring the image as per the requirements. Then we can find out the edge cascade, which is the canny edge detector. There are two cases where we can find out the edges. One is the global way, or the most used case, which is the edge detector. uh, it generally detects the edge of an object, and the second one is the canny edge detect contours. Contours are the very important role, play a very important role, which will be explained later in this video. So this is the code for edge detection or the canny edge detection. The same function is being used, IAMShow function, and here the comes with the deletion function. It is basically the same function, Then comes the eroding an image. For example, if we want to erode an image, then we can use this erode function for the same. And we can also resize an image as per our requirements. And here comes the arguments. Here the cv dot intercubic. In place of that, we can also write here interlinear. But intercubic has a higher quality than the interlinear, so it is widely used as intercubic. And this is the serial size of an erode image. Then we can also crop the image through this function and these arguments. These are the points. These points are the same points which can be found easily through the Microsoft Paint. These are the coordinates through which we have to crop an image, and we can display the cropped image through this IAMShow function. So through this we have cropped an image. For this is the cropped image. This is the original image. So this is the cropped image which will be easily superimposed from this image. Then comes the transformation. If you want to transform an image, uh, for example, if you want to rotate it, rescale it, flip it, crop it, then we can use here transformation function. Here, the rotate function is used to rotate an image. Then we have to specify the height and width for the same, and then the rotation point, which I have explained earlier in this video. Then we have to specify the dimension in 1 unit and then return this whole thing in the function. Then we can also resize an image. Resizing an image is simply we have to pass arguments. The intercubic we can also write here interlinear, but inter we can also write here inter area. Intercubic has a larger size than inter area. Inter area has low quality, but it is faster. So as per the preferences, we can use here, and we can also use here inter area. Inter area basically shrinks the image to a particular size so that we can integrate it in our project. We can also flip an image. Here the we have to find out the name of the image that we have to flip, and then write here 0, -1 or 1. Basically 0 flips the image vertically, 1 flips the image horizontally, and -1 flips the image vertically as well as horizontally. And this is the function which is used to crop an image. All the things are being displayed uh, in this article. I will leave the link of this article in the description below, where you can go through it and also verify it. Then comes the contours. It is the most important part and it is widely used in the OpenCV projects. It is also used in advanced machine learning projects where boundaries of an object, contours are the boundaries of an object, the lines and the curves that joins the continuous points along with the boundaries of an object. Basically, they are the boundaries which are present in a hierarchical form. So through this function we can specify the location of the image. Then we have to find here the we will find here the Gaussian plane, Gaussian blur through this function, and then through Canny Edge detector we will blur the image, and then we will showcase this image through the IAMShow function. So this is the whole program which basically works with the Canny Edge detector. And here comes the color spacing, uh, where we can convert it in an image to grayscale image to HSV format, and we can work out with the image processing. We can convert VGR to RGB also. Then then we can convert a color lab to BGR image. All these functions are easily explained in this blog. So one can refer this blog for more information. These are the this all is been explained is been explained in this log with included pictures. Then in this function we are going to split and merge the any shape. For example, uh, if we want to if we want to uh, blur and if you want blue channel, so we can specify cv dot merge b then blue. Then if you want to merge the red color, then we can specify through this function. And we can also showcase or show the image through the im show function. Then the overall image will look like this. The here, the more the black areas represents the more concentration of that blue color. For example, if we are considering this blue window, then the areas which are in black color are having the more concentration of the blue color in it. And the areas which are colored in blue are having the less concentration of blue in it. And here comes the smoothing or the blurring part of an image. It is also a very important part when it comes to building a more advanced computer vision projects. There are basically four types of blurs. First is the averaging blur, which will basically blur the areas, making the average of the surrounding pixels. Means the it basically averages the blurs which are present in the adjacent pixel and marks the average blur in the central pixel. Then comes the Gaussian blur. It is less it is it makes the picture less blur than the average blur, but it is more natural and it is more useful when it comes to building a project. So, and third one is the median blur, which some noise has been cancelled and substantial amount of noise is also cancelled through this blur. It is not suitable for large numbers. And the last comes the bilateral blur. It is sometimes used in advanced computer vision projects. It basically averages the blur of the two or three adjacent pixels that are present around them. So this was all about the blurring. Now comes the bitwise operator. In bitwise operator, we can work with the shapes, and through bitwise operations such as AND, OR function, XOR and NOT function, we can basically work with the shape. This is also used for uh, masking an image. Masking an image I will explain later in this video. For example, this is an image of a rectangle and this is the image of a circle. If you want to find out the image, if you want to mask these two, then we can write bitwise AND function. Uh, if we write bitwise OR operation, then we are getting this type of result. And similarly for XOR and NOT. How to implement this function that I have explained through this blog, I will leave the link in the description. And then comes the masking. Through the masking, we can work with the XOR and AND function that I have explained right now, and we can mask the image in the shape function. So we are using these two function in this one program. To make the program more clear, I will use the images. For example, this is an image of a cat and this is the image of a blank image. So through this, we are masking this image so that the image uh, of this cats will be cut in the marks masked into the blank image. The result is shown in this weird shape. Okay, so this was sort of all about my side about the OpenCV. There are also various projects, high level projects, which are include the face detection and the eyes detection that I am working on. And I will, I am currently working on these projects and I'm exploring these projects. Uh, Thank you.